So one of the things we're also going to do in this unit is learn the log graph. Okay? The log graph is not hard because it's the inverse of the exponential graph. So if you're trying to graph y equals log base 4 of x, the corresponding exponential that would go with this one same base would be y equals 4 to the x. And you know that your exponential graphs have an asymptote at y equals 0. The two key points are 0, 1 and 1, 4. So to graph y equals log base 4 of x, if every single exponential graph has 0, 1, every single log graph, because it's an inverse, and your x's and y's will get switched, every single log graph has 1, 0. And if your exponential graph had 1, 4, does it make sense that your log graph with the base 4 would have the base, 1, 4, 1? In fact, mental math-wise, can you see that if you plugged in 4 and thought, what exponent gives me that? The answer would have to be 1. Okay? So initially, I'm showing you that you can graph a log because you know how to graph the exponential function. But after this, when you have to graph logs, I want you to go directly to the log graph. Okay? If your exponential graph has y equals 0 as an asymptote, and you switch x and y, your log graph has x equals 0 as an asymptote. And really what's happened is we've taken the green graph, we reflected it over the diagonal line y equals x, and you would get the purple graph. That's how inverses work. Okay? So in the purple graph it says identify the intercepts. It has only an x-intercept. It has no y-intercepts. Equation of the asymptote. The asymptote is at x equals 0. Domain and range. The domain, x has to be bigger than 0. The range is everything. We are going to do our complete transformations unit with log graphs too. Okay? So you have to know what the basic log graph looks like. We'll do a couple more. What number do you want to use? 5? 12. 12? 12. 12. Okay. Wow, that changed color. I just want graph y equals log base 12x. Well, we want to go directly to the log graph. So going directly to the log graph, every log graph has 1, 0. Every log graph has an asymptote at x equals 0. This log graph with a base of 12 will have 12, 1. And once we have that, you can draw its shape. I'm going to see if you remember this or not. Okay? Obviously, it's a log graph. It's going to have 1, 0. It's going to have an asymptote at x equals 0? What other point is on this one? 10, comma 1. Do you remember when it's not written? There's an invisible 10 there. This is called the common log. You didn't remember that? No.
What was that? What year was that?
That's from this unit. This is called the common log.
Oh, it's not from any previous year?
No. When the log is not written, it's called the common log. Okay, we're going to do another one. See if you remember this. Okay. It's a log graph, so it's going to have 1, comma 0. It's going to have an asymptote at x equals 0. What other point is going to be on this one? 2.7, comma 1, because E is approximately 2.7. You were missing for that too?
Yeah.
The number E.
E is 2.7.
2.718281828 and dot goes on forever.
How is E 2.7?
It's on your formula sheet. It's a special number. It's a special number like pi.
I got my calculator right here. Let me see what E is.
Ooh. Does Alexa know about E? I gotta ask her. Like, what is E plus 1? See if it comes up with 3.7. 2.7. E is approximately. Okay. Now, to make things interesting, your calculator likes log E of so much that they have a special logarithm. You see on your calculator you have a log button and you have an ln button. ln is the same as log base E. It's called the natural logarithm. The N stands for natural. L is logarithm, Frenchy. That's why it's backwards. The natural logarithm.
So what's the difference between, like, there's a shift E and then there's an alpha E? One of them is 1.5, the other one is 2.7. What's the difference? Why do you shift E?
That's just
Damn, I got 3.8 now.
here. This when you go shift E. That there. It's asking you to put an exponent in. There. E to the 1. You want x to be 1, you do E1. You want x to be 2, you do E squared. All right. So the natural log of x. So when you see, right, when you see something like this, what is natural log of 10? This is the same as asking what is log base E of 10. In other words, E to what exponent is 10? I guess it's just a little bit bigger than 2. But you could type it in and find out what it is. Natural log of 10 is 2.3. Okay, so graphing practice. You can circle questions 10 and 11.